Right now, 25 billion kilometers from where you're sitting, a machine older than the internet, older than cell phones, older than most of your parents, is still awake. It runs on a computer with less power than your microwave. Its batteries are dying. And a few months ago, it sent home a signal so strange that NASA engineers sat in a room in Pasadena and just stared at it. This isn't science fiction. This is Voyager 1. And what it just found, and what NASA had to do to keep it alive to find it, is one of the strangest stories in the history of space exploration. Let's rewind. September 5th, 1977. A Titan Centaur rocket lifts off from Florida carrying a spacecraft the size of a small car. Its mission? Fly past Jupiter and Saturn, take some pictures, phone home. Maybe last 12 years if the engineers were feeling generous. That was the plan. 49 years later, Voyager 1 is still transmitting. It has left the sun's protective bubble entirely. It is the single most distant human-made object in the universe, and every single day it pushes that record further. But here's the thing nobody tells you in the history class version of this story. Voyager 1 should not still be talking to us. Its power source, a chunk of decaying plutonium called a radioisotope thermoelectric generator, loses about 4 watts of output every single year. It's not a battery you charge. It's a battery you watch die in slow motion for 5 decades. And in 2026, that slow motion death sped up during a routine maneuver on February 27th of this year. A simple roll, the kind of thing Voyager has done 1,000 times without incident. Mission engineers noted something they did not want to see. Voyager 1's power levels had dropped, unexpectedly, without warning. For a spacecraft running this close to the edge, an unexpected power drop isn't a glitch, it's an emergency. Every watt on Voyager 1 is already spoken for. There is no slack in the system, no spare battery in the trunk. When you lose power you didn't plan to lose, something has to go dark to compensate permanently. So the team made a call that sounds almost brutal in its simplicity. They shut off one of Voyager's remaining scientific instruments, not because it stopped working, because keeping it on might have killed the whole mission. This is the reality of flying a 50-year-old spacecraft. Every choice is a trade. Every discovery costs you a piece of the machine that's discovering it. But here's where it gets interesting, because this sacrifice wasn't the end of the plan. It was the opening move. NASA's Voyager team has a nickname for spacecraft engineers who keep pulling off the impossible with a machine that should have died in the Reagan administration. They call it having a good track record of performing miracles that stretch the power supply. That's not marketing spin. That's a direct quote from the mission's own engineers, and in 2026 they attempted their biggest miracle yet, an upgrade the team internally nicknamed the Big Bang. The plan. Rewrite and upload a patch to Voyager 1's onboard systems that could potentially let engineers restart science instruments that had already been shut down to save power. Instruments the world had already said goodbye to think about what that actually means. This is a spacecraft where the round-trip communication delay is now pushing 48 hours. You send a command, and you wait 2 full days to find out if it worked, or if you just bricked humanity's furthest flung machine by accident. There is no undo button. There is no tech support line. There is a team of engineers, a signal crawling across the solar system at the speed of light, and 49-year-old code that nobody who originally wrote it is still around to explain. And somehow it's working. Slowly. Carefully. One command at a time. Now here's where we get to the part of the story that actually earns the word impossible. Even though, as you're about to see, the real answer is even stranger than the clickbait headlines are giving it credit for. When Voyager 1 crossed the heliopause in 2012, the invisible boundary where the sun's influence finally gives way to true interstellar space. Scientists had a model, a prediction. They expected the magnetic field to shift dramatically in direction the moment Voyager crossed over, like walking through a doorway into a completely different room. That's not what happened. The magnetic field on the interstellar side looked almost the same as the magnetic field on the solar side, nearly the same direction, nearly the same strength. As if the doorway didn't really exist, as if the transition between inside the sun's bubble and the empty vastness between stars was far blurrier than physics said it should be. That finding alone rewired how scientists think about the edge of our solar system. It suggested the heliosphere doesn't end in a clean line. It fades, tangles, and blends with the interstellar medium in ways nobody had modeled. But it gets weirder. Once Voyager was confirmed to be in interstellar space, its plasma wave instrument picked up something scientists did not expect at all. Temperatures in the surrounding gas were extremely hot. Tens of thousands of degrees. Hot enough that, if you were standing there, common sense says you'd be instantly incinerated, except you wouldn't be. Here's the twist that even most science channels skip over. Temperature and heat are not the same thing. That plasma is scorching hot on a per-particle basis, but interstellar space is so close to a perfect vacuum that there simply aren't enough particles around to transfer that heat into anything. You could theoretically stand in gas, measured at 50,000 degrees, and not feel warm at all, because there's almost nothing there to touch you. It's one of the strangest, most counterintuitive facts in all of space science. And Voyager 1 is the only human instrument that has ever actually measured it directly, 48 hours communication delay and all. Let's talk about the scare that nearly finished Voyager 1 off before any of this year's drama even started. Back in November 2023, Voyager 1 suddenly began transmitting complete gibberish. Not silence, gibberish. a repeating pattern of ones and zeros that meant nothing. For months, NASA engineers had no telemetry, no science data, nothing but a heartbeat signal proving the spacecraft was still alive and still listening. The cause, eventually traced across billions of miles and months of detective work? A single corrupted chip in the flight data subsystem, one of Voyager's 3 onboard computers. A chip that had, after 46 years of continuous operation, simply started failing. The fix wasn't a chip swap. You cannot send a repair technician 22 light hours from Earth. Instead, engineers did something almost absurd in its ingenuity. They rewrote the corrupted code and split it up, relocating pieces of it into different unused sections of the spacecraft's memory, patching around the bad hardware entirely, using software alone on a computer system designed in the 1970s. It worked. Voyager 1 spoke clearly again in the spring of 2024. That fix is why the Big Bang upgrade in 2026 was even possible. It proved the team could still perform open-heart surgery on a computer twice as old as most of them, from a chair on Earth, with a 2-day delay between every single keystroke and its result. Which brings us to the milestone this whole story is racing toward. In November of this year, Voyager 1 will cross a distance so vast it barely fits in a normal sentence. 1 light day from Earth. Almost 26 billion kilometers. 16 billion miles, a light day means exactly what it sounds like. If you sent a radio signal from Earth right now, at the fastest speed anything in this universe is allowed to travel, it would take a full 24 hours just to reach Voyager 1. Then another 24 hours for its reply to crawl back to us. Every command NASA sends. Every update. Every attempt to squeeze one more year, one more discovery, one more mile out of this dying spacecraft, it now takes 2 full days round trip just to find out if it worked, and they're still doing it. Still sending commands into that 2-day silence, hoping the answer that comes back is good news. So let's be honest about the headline that probably brought you here. NASA hasn't confirmed anything that defies the laws of physics. Nobody at JPL is claiming Voyager 1 found aliens or broke a law of nature. What they have confirmed is arguably better than a hoax, because it's real. A 50-year-old machine, running on dying batteries, still teaching us things about the space between stars that no simulation, no telescope, and no theoretical model got right on the first try. The blurred magnetic boundary, the scorching but harmless plasma, the self-healing code patch performed across a 2-day communication gap. The team pulling off a power-saving miracle just to keep the lights on long enough to try for one more. Voyager 1 was built to last 12 years. It has now operated for nearly 5 decades, and it is still, right now as you watch this, the furthest reach humanity has ever had into the dark. It carries a golden record on its side. Whale songs, greetings in 55 languages, a map back to a small blue planet, in case anything out there ever finds it. Nobody knows exactly when it will finally go silent for good. Every year, the engineers say they've bought one more year. Every year so far, they've been right, but eventually, the streak ends. And when it does, that machine won't stop moving. It'll just stop talking. Sailing on, forever carrying humanity's voice into a darkness none of us will ever see. If this blew your mind, that's the whole point of this channel. Real space science, told like the wild story it actually is. No fake headlines required. Scoob if you want more of these. Drop a comment. What do you think NASA should try next to keep Voyager alive? And if you want to go even deeper, check out the video on screen right now. We'll see you in the next one.